Welcome to EDU World Space.
So there are two light bulbs, right? So one is 400 and one is 800 ohms. Let me write that here. R1 equals to 400 and R2 equals to 800. Now these are both in ohms. Now if they are connected in series across, voltage is given fixed, that is 120 volts. Now first they are connected in series. So let me write that here. Connected in series. So let me highlight this first. So if they are connected in series, so the first question number A asks us to calculate the current through each bulb, right? So to calculate the current, first let me calculate the equivalent resistance. This is equal to, since they are in series, it is R1 plus R2, right? So if you add R1 plus R2, this comes out to be 1200 ohms, right? So from this we can calculate the current through the system, that is equal to V upon Req. Now V is 120, Req is 1200, so I equals to 120 by 1200, that is 0.1 amperes, right? Now since the resistance are in series, so this is what the each individual resistors did. So I1 equal to I2 equals to 0.1 ampere. Is it this what it has to calculate? Yes, current through the each bulb. So we are done with part A. So let's move on to part B. The power dissipated in each bulb. Okay, so power dissipated in first bulb equals to I1 squared times R1. Now I1 squared is 0.1 squared, R1 is 400, so this is simply 4 watts. And power across 2 is equal to I2 squared R2. Now I2 squared is what? Uh, Again the same 0.1 squared, R2 is 800, so that is 8 watts. Right, so we are done with part B of the question. Now the total power, we can calculate this here. So the total power P is equal to power from the first bulb plus power from the second bulb, that is equal to 12 watts, right? Okay, so we're done with part C. Now the question says that the bulbs are now connected in parallel. Connected in parallel. Right? Right. Okay. So since they are connected in parallel, so first let us begin with again calculating the equivalent resistance. So Req is equal to now R1 parallel R2. So that means this is equal to R1 R2 upon R1 plus R2. Now what is R1 R2? 1200 upon 8 4 are 32, 3200. So 1200 upon 3200 upon 1200. This is equal to 266.67 ohms. Right. So the current that is that starts when the current that comes out of the battery is V upon Req. Now V is 120 and Req is 266.67. So this comes out to be 0.45 amperes. All right, now since the bulbs are in parallel now, so the current won't be same, the current will be divided, and it will be divided in such a way that I1 will be equal to in inverse ratio of their resistance. So R2 upon R1 plus R2 times I. Right. Now we know R2 800 upon 1200 into 0.45, that is equal to 0.3 amperes. Right. Okay. Now, similarly, I2 can also be calculated the same way or even an easier way, because the total current was 0.45 and uh, R1 got 0.3, so R2 will get the difference, that is 0.15 ampere. Okay, so we are done with calculating the current across each. So this is part D of the question, right? Yeah. Now let's move on to part E, that asks us to calculate the power dissipated. So again, using the same formula, power dissipated equals to I1 squared R1. Now this is equal to 0.3 squared into, what is R1? 400. So this comes out to be 36 watts. Similarly, P2 is equal to I2 squared times R2. So this comes out to be again 0.15 squared times 800. So this comes out to be 18 watts, right? Okay, so we are done with part E of the question. Now let's move on to part F here. So in F, we have to calculate the total power. So the total power P equals to again P1 plus P2. So there is 36 and 18. This gives me 54 watts. Okay, now let's move on to part G of the question. It asks us, in each situation, which of the two bulbs grow the brightest? Okay, in series, when they were connected in series, which glowed the brightest? Here, uh, power dissipation by the second resistor, that is 800, it was 8 watt, and the first was 4 watts. So 8 watts, right, is brighter. So in series, 800 ohm was brighter. Right, and when in parallel, which is brighter? Let's see. So P1 is 36, P2 is 18, so R1 is brighter, that is 400 ohm is brighter. Okay, so we are done with part G of the question. Let's move on to part H. In which situation is there a greatest total light output? So the total light output was 12 watt when connected in series and 54 watt when connected in parallel. So when parallel, the total power output was higher. So remember, if you want a brighter room, so connect the bulbs in parallel. If you want to conserve your energy, electricity, connect them in series. Okay, this is the solution to this problem. Thank you for watching.